morning, good afternoon, good night, depending where you are joining. Happy to be here. Thank you for joining this webinar. We're going to be talking about the performance monitoring and improvement of your application using Koin. And for that, the idea is to compare two monitoring tools, the Kotzilla Platform and Firebase Performance Monitoring. So it's going to be a live session. I'll be your host. I'm Miguel, Product Marketing, and I'm really happy to share the floor today with the one and only Arnaud. Probably you know him, Koin lead, co-founder of Kotzilla. How are you doing, Arnaud?
Hello, Miguel. Thank you. Thank you very much. Very happy to share this session with you today, and we have many great stuff to show.
Exactly. Okay, so let's go. So I'm gonna move to the the agenda. You will see that it's gonna be the majority a live session, but just to give you some context, I'm going to start by presenting a little bit how we did this comparative. So which app are we using and what is the setup? And then after that, we're going to go into the two demonstrations. There's going to be live demonstration for Firebase and Kotzilla. I'll do the Firebase part, and then we switch the floor to Arnaud, that is going to go in details into the Kotzilla platform. And we'll save some time for Q&A and any closing remarks. If at some point you have questions, so please drop them during the session in the chat, and then during the Q&A, we'll look to the questions that are there, and we'll try to answer. If that sounds like a good plan, let's gonna move to the the setup, and then the live demo. So here is kind of the main info. We're gonna be using the Now in Android application. Probably you know this one, the reference app by Google. In this case, of course, we're using the Now in Android version using Koin that is available in the Kotzilla public repo, GitHub repo, if you want to have a look. For simulating interactions from users, we're going to use the Android 14 emulator inside Android Studio to run different user sessions. Here you also have the different versions of the SDKs that are be part of the demonstration. And then the most important part, those are the issues that we have introduced to then see how each platform behaves, and what are the main difference. And you probably see here that they are quite common performance issues. So the first one is going to be a 1 second delay that we are going to introduce in a view model, and it's going to create a UI freeze. The second one is a big 10-second delay to really make sure that we simulate a slow startup of the app. So the time which the first screen of the app becomes usable. And the last one is going to be, we're going to introduce a 1 second delay to create a background lag. So, something that is running on the background thread. And we're going to see if those are detected or not, and which kind of information we have to solve those issues. Okay, so enough slides. Let's go to the live demo. As I mentioned, I'll start with the Firebase part. Let me just probably share my whole screen here. Share my entire screen. Hopefully you can see my Android Studio. Okay, so let me show you how the configuration of the Now in Android for Firebase looks like. You see here that I'm using the Now in Android. I'm using the default branch, which is called Koin Start. And the setup is quite straightforward. So I'm in the build Gradle file at app level, as this is an Android app. I'm just adding the Firebase plugin. Also, you will find at the bottom the implementation. Notice that I'm also using here the Crashlytics. I'm not going to demonstrate the crashes here, but just one main difference between the two platforms. In Firebase, you need two different SDKs to monitor performance and also crashes. Today, we're going to be focusing on the performance one. So that's the config at app level. Then we also, at build Gradle file at root level, we need to define the Gradle plugin. So that's what I'm doing here. And last but not least, in our application, in this case, the new application, I'm also using here the Firebase API, the SDK API, for two different reasons. One, because this is the main use case, or the main way in which developers are using Firebase. So start traces, stop traces, and really try to go deep into instrumentation, but manual instrumentation. And second reason is that with Firebase, there is no guarantee that when I click run, my session is going to be recorded. So what I'm trying to do here is that adding a manual trace to force that at least a sample, what is called a sample user session, is recorded, because otherwise probably we don't have any information. No? So yeah, that's what I'm going to do. You notice that I already introduced it, the 10 seconds delay in the application class. So this is the one that will create the slow startup. If I show you the other issues, here you will find the 1 second delay in the view model. In this case, is the main activity view model, if you are familiar with now in Android app. And same thing here during the initialization of the sync worker. I'm simulating the 1 second delay impacting the background. So that's the setup for today. So I'm going to click on run, and we're going to see how Firebase behave. Notice that I activated here logcat, so we can also see that different traces that are generated, just in case there is some demo effect. So here I'm launching the Now in Android app. So sharing some useful content. So I'm gonna be clicking around just to make sure that we generate some data. So that's would be probably enough. And I'm gonna stop. So as I mentioned, probably this will not generate a user session in Firebase. It's kind of random. Even during development, only between 1 and 5% of the user sessions are recorded. But hopefully that creates at least a sample, so we can have a look in the console. So let me switch to the Firebase console. Let me do a refresh. Okay, here we go. So we have here the main metrics, or the default metrics that you can see in Firebase if you are really using the tool. So there are 4 ones that are available kind of out of the box. So the first one is self-explanatory, the startup time. The second one is the time that the app is spending in background, meaning like not user interaction. The third one is the user interaction time, so the app in foreground. And then by default in Firebase, you have also a metric about the rendering of the first screen. Only the first one. For the other ones, you need to go with custom traces, but you get at least this one. No, you can also add custom metrics. So if you remember, I added a custom trace. So if you go to custom trace, then you see here that we have the default one that I was talking about, but we also see the test trace startup that I manually added. So we can add it here. And to get additional info. No? So let's try now to do some analysis on what happened after running that user session on the 3 main issues. No? So let's start with the app startup time. So it looks like Firebase was able to detect that something went wrong here. Here I'm filtering for the last 24 hours, and we see that I was running also yesterday some user sessions. So not sure that it captured exactly the last one. So yeah, it captured the last one. Here we have the 4 p.m. If not, sometimes you have a trend. But in this case, we got that sample. We don't have the whole user session, but we have the sample. And then we can try to go deeper and analyze a little bit what went wrong here. So we can see, for example, kind of the same information. We can try to see if there is any user session recorded. Actually not. You see here, we have some samples, but no user session. So if I try to view here the additional information of the sessions, of course, I don't have anyone available. So what I'm going to do is I'm going to filter for the last 30 days. As you can imagine, I was doing some tests before the webinar. So during the last days, and we have 4 user sessions that were recorded. Among, I don't know how tens of them I run, but at least that gives you, a sense also of the information that you can get when the user session is actually recorded. So you see, yeah, it's nice because you have some info about the CPU consumption and the memory consumption. You have some visibility here about, the app startup took, more than 11 seconds. And if we can even see the manual trace that we added, in that initialization that was the 10 seconds. but we don't know exactly much more. We don't know exactly in the code. I mean, we added that trait in the code, so we have information because we knew it in advance, but there is no additional information about any component that is, or any call, any external call that could be causing that. It's actually the same if we try to have more info, for example, on the first screen rendering. As I mentioned, this is a metric that we get by default. Here, I'm still using the last 30 days filter, so we got more than 34 samples here. Actually, we don't have much more information. We have new metrics that appears. I don't know if you are familiar with those ones. So we have info about slow frames and frozen frames for that particular screen. Actually, a frame in Firebase is the single screen refresh. And a slow frame means that it took more than 16 milliseconds. Frozen frame means that it took more than 700 milliseconds, which is expected because, we have this 10-second delay in the app start. But again, it's not giving us more information. And again, this is only for the first screen. If you want to have more info about other screens of your app, you need to do that manually adding your custom traces. So bottom line here, the Firebase was able to detect the app startup, but we are not getting additional info exactly which part of the code. Let's see the other two issues. Remember the 1 second delay in the view activity view model that is breaching potentially, the UI and blocking the main thread. Maybe, initially I was trying to say like, maybe I have some info in the app foreground because that's the interaction with the user. So if we try to go here to the metrics, still using the 30 days filter, so what we see is that the pattern has changed a little bit in terms of the time for each one of the user sessions or the samples recorded that the user was interacting with the app. So it goes from 11 seconds here to more than 1.5 minutes, and the last one that I recorded was just some seconds. So yeah, so you get a feeling of the trends. You can also have some filtering by percentile to get some trends, but there is nothing here that let us know that there was a 1 second delay on the main thread. This is just on the time that the app was interacting with or the user was interacting with the app. So we don't have, even if we go with the view additional details of the session, we have kind of same view than before, the CPU consumption. We also have in the device the time that the app was in foreground, but I'm not collecting here any network data. So if you collected some network data, some external call, maybe you will have it here. But this issue went completely unnoticed for Firebase. They don't have any indication that which component is causing the problem, and it's not even a problem, that has been detected. Actually, something similar happened with the third issue. Remember the one that we introduced in the sync worker. So maybe same kind of reasoning. We could thought that some info will be available in the background metric. But yeah, that's similar to what we saw before. No, this is just the time of the app was spending without any user interaction. If I well remember, in that case, we don't have much information besides of the duration for each one of the sessions recorded in which the app was in background, but yeah, no information about thread execution, which is something that will be really helpful to understand, okay, which was the thread that was impacted, what are the main thread, what was the background thread, and what was the issue, and was related to any component long resolution, was related to any complex dependency graph. This info is not available, and as I mentioned, the only way to get it is to basically add manual custom tracing, which I think it can be difficult in that scenario because you don't know in advance which view model or which screen or whatever is going to get impacted. So usually I've seen a lot of developers in advance trying to define what is the critical path of the app and trying to add a lot of traces to get some information when something happens. Before switching to the Kotzilla demo, I also wanted to just highlight what I was introducing before. So I've also configured the Crashlytics SDK and even generate a crash here. But I wanted to also, illustrate that, you need two different SDKs. If you are using Firebase for catching crashes and performance issues. You have two different consoles, and the user sessions cannot be combined. So you don't have a same visualization in which for the same user session, sometimes you can have, I don't know, a performance issue that is going to end up being a crash. So you don't have this potential correlation, or you need to do it by hand. No, you need to do custom code again. So hopefully that gives you a good overview of initial overview of how Firebase behaves there in this particular example. So I'm going to switch to Arnaud, and we're going to see exactly the same example and in Kotzilla. Arnaud?
Yes, sure. Thanks, Miguel, for all of this. Yeah, I take the end of the screen sharing. I will show you some code to start, right? Yeah, should be okay. You should see my Android Studio, right? Then, as Miguel said, this is now an Android application, the application developed by the Google team to develop and to demonstrate all the blueprints of the regular best practice of Android development and Compose, of course. And this is clearly a great materials for us to also demonstrate some great pattern. I took the same application, the same one as Miguel, right? And the only thing I added is the Kotzilla monitoring that is really taking advantage of the built-in monitoring features of Koin to help us really have more deeper insight from the application and have more advantage of information about with the Kotzilla platform. I won't go into details about the application itself. You see it's a regular start Koin block here, okay, right? Then it's just the migrated application that you can find on GitHub. Then you can re-download it, and then you have this version that is particularly running. I put also the same, this is the same version. This is where we put also some super blocking stuff in the application to try to see if we are finding the same issues, of course, and what kind of data we can find. Let's go into the setup, right? And as you can see, the main setup from in my code is one line over my my Koin configuration startup is one line called analytics. This analytics function will clearly take my configuration and then communicate with the Kotzilla server and then really help me analyze what's going on. We have the understanding of your applications in all the structure of the life cycle, and then we will be able to understand your memory allocation, your performance in terms of how your architecture is being created, and then we will see that more in a deeper way. Then to add this line, this magic line that is activating all the analytics for us, then to do that, you need in your Gradle catalog file, you need to add Kotzilla version, of course. Here I'm using Koin 4.0, but you can really use that with Koin 2.5 to Koin 4.1, the latest one, right? It's also compatible to with the Koin notation application. If you are using Koin notation, you are clearly compatible with that. And let me expand a bit the details. And here you need, and we have a version. You need a library called Kotzilla SDK Compose. We have SDK that will use some Compose features that we show you. And we have lastly a Gradle plugin, the Kotzilla Gradle plugin that let us prepare the thing for you and then help you start. Then mainly you have this version, and then you need just to prepare the Gradle plugin, right? And then in your application, I just changed the version, and then I added the Kotzilla Gradle plugin. And in my libs, I just added implementation of my Kotzilla SDK. And you will see I added just an options here that I can activate is the Compose instrumentation. We'll see that. We can understand how your Compose screens are working, and mainly we intercepting the Compose navigation part. And also this section is useful if you are making some multi-platform setup. We are compatible with multi-platform setup, but we might require a bit more side information here. But then in Android application, it's quite automatic. Then you even almost don't need this Kotzilla section if you don't use or don't want to intercept the compose navigation part. And that's mostly it. The only thing you need after that is once you have registered a free account on the Kotzilla platform, Kotzilla.io, you can sign up and then you register an application. Then you can go on the platform. You register your application you want to be monitored like in Crashlytics, exactly the same package ID, my app name, and that you have all the setup instruction for you to have the right libraries to use and the key. It's like the Firebase stuff. We have just a file for you that you put. You see here, you put that in your app module, and then you're gone. Then that's it. Mainly, you just need one line. You just need one key file, and then we will generate some stuff for you. But then that's it. You have the library, you have the plugin, and then you can go on. Then you can run the application. I already run a bit of stuff. Before that, before going onto the platform to see what I've just run while Miguel was showing the Firebase platform, you can also connect with your Kotzilla platform, with your Kotzilla account. You can activate the Koin plugin. That means that, for example, if I go in one of our modules, for example, you see that I have decoration around all my Koin configuration to understand what are the usage. You see, I can go directly to where I'm using this or this definition here. All my code is analyzed on all the usage, understanding navigation from and to my definition. And then you have all your architecture and configuration here. Even what we have is that from the Koin plugin, you can have a life safety compile check. That means that the plugin, when you work on your project, the plugin will analyze if you have default in your application, and then if you miss something in your configuration. Then, for example, here, I gently remove one of our DIO in our data layer. You see that we have warning everywhere, and we have underlined lines here. We have clearly warnings about what's going on, and there's a problem in my code. Then lively, you don't have to rebuild all your stuff. This is the work of the IDE to analyze your code. And then you have the navigation, the life safety, and then all of this is accessible with the Koin ID plugin that you can find on the marketplace, the JetBrains marketplace. You just open the plugin installation of Android Studio, and then you're done, and then you have access to the Koin plugin. Yeah, I believe that's nice. Then you have this tooling, and I will show you that even we have here insights in the plugin that are detected from the platform, like local configuration. Then I was showing that if I have local configuration, I have something here, and then we have issues detected here, right? Even you have a flight check. That means that we are checking if your Kotzilla SDK is well configured, and then if you connect it to the platform, and if you are ready to go. I guess that's okay for now, and we can jump on the platform right now. For those who don't know the application, the Know in Android application, it's a news application that I can restart, for example, and we will show you that we managed to make a blocking startup. We fake a blocking startup, right? Trying to have something really to emulate. You see the splash screen is super long. Yeah, and then you're going here in this application where you have your topics, and then you can select things you would like to look at. For example, save article. I unsave some of them. You can activate some stuff, etc., etc. And then you can go to category. Then it's really interesting because there are multiple screens. It's not just an ELO or to-do application where you just add you have two screens. It's quite interesting, and already we have stuff to show. Let me now take the hand to stop sharing and then show you the platform now that we have data online. Yeah. Here we are. Then we are on the platform here. You see, I run the many sessions, number of events we have, and then directly you have an overview of the critical issues we have detected. Then in terms of overview, as I was saying, we understand your application because we know Koin, we know all the core of your backbone of your application. The thing is then, we know everything about your application in terms of how it's running, in terms of building blocks, right? From your view model to all your components, and even we can understand your activity, your fragment, and then your navigation in terms of compose screen, right? Then you have several screens. You have dashboard, an overview of what you have been detected and what you have in your current versions. You have also issues here. Then you can have a main thread. We have several critical issues. We have main thread issues, something that is blocking your main thread. Then Miguel was saying, startup issues. We detected that your first screen was delayed, and then there is a problem that then we can investigate on that. Also, we have a background worker, a sync manager in Android that is trying to offload all the news that we want to read. And even if we can intercept crashes like in Crashlytics, like I can show here, you have the stack trace, you have everything here. And then you can really dive into next session too. I will take one of the first issue to let you understand how we can jump from the platform, from the issues, and then even try to debug and investigate in current stuff. Then, for example, if I click on an issue here, I have a blocker in main activity view model, then it's blocking my main thread red. Then that means that it's more or less doing like almost ANR, and then it will impact my user. Then some of my users that don't have high-end devices will have bad performances, will have lagging stuff, and that's really not good. And then for all issues, you can really jump into what we have in a timeline. That means a user session that has been recorded, and then we can understand what kind of we can understand what was doing our user really. Then I can show you. You see here we have then a quite complex, complete screen where we are focused directly on here. This is our log view. Okay, we have on top we have a highlight of the overview of all the UI activity and issues. Then, for example, I have screens activity. I have compose screens that have been triggered. You have the memory allocation in terms of DI allocation, what you try to do, what you try to create, what you already have in memory. Are you creating with factories? Are you creating with cops, etc.? And you see here we can even have like a threading CPU analyze graph where we understand where you were doing what. And then, for example, we clearly highlight, for example, the 1.5 second delay in our view model, and directly here I can really understand. I can really point my open my timeline, investigate on that, and even look at the first stuff here. I have a detail of the dependency graph, details on the definition, and even here I begin to have an explanation of what's going on, right? Because okay, I have an activity, my main activity view model that is lagging. Perhaps it's something that comes from one of the child dependency. Perhaps it's something else, but all the dependencies seems to be okay. You see, we are loading things in 0.07 milliseconds or 2 milliseconds. That's fine. That means that we might have problem in initialization, in the main initialization case, and this is where clearly we pointed main activity. We plotted thread blocking in the main activity view model constructor. And you can even see here, I will go back on that. You can even see here that we can ask more details, more context, and even ask for help for a prompt. That means that we can help you investigate this issue. We give you data, we give you context, because really we understand from what classes you impacted, what was the problem, where it was located, and we have real data for you that comes from your production. Then you can really try to solve it directly with your favorite AI model, right? I come back on that. This is the main thread. This is the main thread blocking issue. If I show you the source code, you will see that it's in the blocking stuff. We have also the slow app startup time. If we open what we were doing, for example, I will show you here. This is my startup process. We see that we have many stuff, and we have this screen that has been delayed far away, and we have a startup problem. That means that this screen took more than 5 seconds to appear, right? Then the good thing is that you can begin to investigate on that, and from the source code, you can really understand what we were doing and what was blocking something great. Then we have directly you see this this issue that is marked here in our timeline. And lastly, also, for example, we can even detect background problem. Like we have a problem with a worker that is doing background work. That means it's not on the main thread. It's something where you see here, it's on thread VM task 1. And this thread is taking, this block of component was taking 1 second. Again, we try to simulate a problem in the constructor. And then we have the result of this component. You see, this is a background worker where we are loading many components. We have many subchild dependencies. And you have the graph, you understand really what you have here. And then we understand, you can begin to investigate on that. And even here, the same, there is no impact in other dependencies, or we don't detect anything else in other components. It might be initialization. And of course, here it doesn't come from a, we might have, for example, a laggy components here. You see, search component repository that could be a bit laggy, but it's not a critical issue. The critical issue here is that our worker is taking lots of time to load and to do something. And then here I have directly all the content to do that. What is interesting also in terms then of data, you see that I have all the state of my activity. Then it's created, started, and even here we have the navigation part here that we have the navigation rules that are triggered. I believe we have a tooltip here, but you know what navigation in screen you were triggering. Then it was a navigation for here. Yeah, it was bookmark route. And here we have another one here that was for you, interest route, etc., etc. Then I have really a tour of what's possible in terms of data, and then now you see that you can really look at every kind of impactful issues from Koin directly analyzed in your application, and then that's super interesting. I will finish. I believe the time is flying a lot, and I will just show again the IDE, of course, to show you what we will also deploy soon, and we are currently deploying, is that you have the Koin insight, then inside of your configuration, as I was showing. Application issues, you find exactly everything you were looking at. For example, the main activity view model here. with the main thread. And then soon you will be able to ask for a prompt to be able to fix that in your Giuliani, in your Copilot. Directly you can copy, and then you can ask a prompt for that. Then it will be here, and then you will see, you can really click directly. And then, for example, you see that in my main activity view model, I have a marker that says I have critical problem detected by Kotzilla. Then I really need to look at that. And then next version of the plugin, in the next days, you will see that even you can even ask help from us, because we understand your data. From your data, we can help you, and then forge a real context that that will help you fix your application. Cool. Yeah, I believe that's it. You see that we intercept also compose, and then you imagine that this is the kind of stuff that you will be able to see with the Compose multi-platform setup, right? Then we make a big tour of the platform. Then to wrap up quickly, after that we'll take a few questions. You see on top of your Koin configuration is just one line. You activate the built-in monitoring, and then you can send your data. It can be debug, it can be production, and then if you are going to production as Crashlytics, you can upload your mapping file, and it's automatically done by our plugin. Then if you want, you can send your release mapping file, and then once you are sending your data, then you will be all the analyze, all the deep focus of everything that is going into your application, and then understand if your application is blocking on the main thread, if you have UI screen freeze due to your DI or some component, if you have background problem, if you have started problem. Even we can catch the crashes exactly the same way as a Crashlytics is doing. Yeah, then everything is free available. Then you just need a Kotzilla account that is free also, and then you can download the plugin. You can register your application, and you can play with a free account on the Kotzilla platform. Thanks. That's it, I believe. Hope we made a great tour of the platform. We can take a few questions, even if it's in the chat. If you don't want to talk out loud, we can take a few ones if you want. Thank you very much.
Yeah, well, we are waiting for some questions. So hopefully there was a lot of information in 30 minutes, but hopefully that you saw the main difference also in terms of approach of the two tools with Firebase, which everything needs to be it's about custom traces, and you need to really think about that in advance. And in Kotzilla platform, in which we have a built-in approach, everything is out of the box. Of course, if you also want to or you are used to work with traces, you can also use the Kotzilla SDK to, in addition to everything you get out of the box, to add your own custom tracing, but you can limit that to really some really deep investigation. No? So we didn't cover that today because it was not the main intent, but just to let you know that if you like that approach and you also want to add your custom traces, you can do it as well with the Kotzilla SDK. I think we have a question from Jeremiah. So to get the best out of the Kotzilla platform, should we prioritize projects using Koin for DI, since projects using other DI frameworks will only benefit from generic crash reporting? I can take this one. So yes, I mean, it has been built for Koin, and built by the curators of Koin. So yeah, so you are going to get all the, especially the level of info that was showing today, Arnaud, in which you are able to see the component and all the dependencies. Of course, we are able to do that because it has been on top of Koin. Then, of course, we have plenty of other materials about, we've seen for over the last 2 years, a lot of people migrating from Hilda to Koin, especially because of our native support for KMP and CMP now. So we are also have some material that we can share with you guys if you are using other DIs, whatever that is Hilt or Codeine, in which we explain how to do it step by step, and also even how you can do it in a way in which the two frameworks can work together. So you can do a step-by-step migration, and at the same time introduce the Kotzilla platform to start seeing also the benefits. So that's also an approach that you can do.
Koin has also annotation for those who don't want to make or use the Kotlin DSL itself. Then there is also the annotation that is super close to, let's say, the Java standard annotations, and then you will find the same flow and the same productivity as you were used to. Then yeah, you can really benefit from Koin and Koin annotation that both are really compatible with the Kotzilla platform. You benefit from all the built-in features.
There is any other question? Well, we are also waiting for other questions. So something that I'm also here sometimes is like, do we need to replace Kotzilla by Firebase if we are already using Firebase Performance Monitoring? No, you can keep both. I mean, Firebase do a good job about showing you some trends, as we saw, and some vitals. And if you have invested on that, okay, you can keep it, but it's just that you are not getting the same level of visibility. So if you want to get this level of visibility and trying to anticipate issues and fix them faster, so you can combine that with the Kotzilla platform, so you can use the two together.
Both crash reporters are compatible. That means that you can really collocate Crashlytics and Kotzilla. This is what we have now in Android. We are collocating both, and then if you have crashes, then both the crashes are going on both platforms. Then there is no override for the Android crash reporter on this side.
We have another question, which is an interesting one. It may sound weird, but it's actually not weird. But I have an application with no network permission at all. It's possible to use the Kotzilla Performance tool without network permission. I have an initial element, but maybe Arnaud, you have a.
Yeah, our network is using a communication, and then you need connected platform for that. Then yeah, it is a requirement for us to have connectivity.
Maybe what we can add to that is that there is another use case. I don't know if it's possible for you, but we have some users that they have connection, but not all the time. And in that situation, the SDK is able to manage that. So if you go offline from time to time, we are able to buffer this information and then retry. So of course, at some point you need to have some connection. But if the question was, or if you have a use case in which you can lose the connection, this is handled natively by the SDK. But of course, at some point we need one connection.
In terms of dependency, you don't need the Google Play services. Then it's fully Kotzilla is a full multi-platform project. Then you have the setup, and we are using Ktor internally to communicate. And basically, this is all we do, like really communicating with the network. No big fancy stuff on that. But then you don't need really Google Play services or pre-required heavy library like that.
We are perfectly on time. I don't know if there is any other question. We can take, I think, one more. If not, just in case what you are thinking about the question, a couple of links here that we wanted to share with you. So Arnaud was telling about the Kotzilla.io. You can create an account there. And you also have here the link to the documentation, including the Getting Started guides. And if you missed the article about comparing the two platforms, you also have you can scan here the QR code. You have like the similar demonstration that we did with Arnaud, but in an article. Sometimes it's better to read it, or if you want to share it internally, so you can just scan. It is available in our blog. Okay, so thank you very much. Thank you, Arnaud. And thank you to all of you for taking the time.
Thank you, Miguel. See you all.